So we can go ahead and get started. Just to let everybody know, this session is being recorded for later viewing for those that aren't able to attend. My name is Eric Syme. I'm a Director of Program Management with ProSoft Technology. And so what I'll be doing today is giving you an introduction on some of our latest PROFIBUS products designed to meet some of the most demanding PROFIBUS applications out there. These are kind of a culmination of years worth of PROFIBUS experience. ProSoft started selling PROFIBUS products about 18 years ago, I believe. And these are some of the latest additions to our product portfolio that I'm kind of excited about, and look forward to introducing you guys to these. If you have any questions that pop up, please use the online chat form. You can see that in your meeting window. So please feel free to ask any questions as they pop up. And with that, we'll go ahead and get started. So these products are part numbers PLX51 PBM and PLX51 PBS. PBM stands for PROFIBUS Master. PBS stands for PROFIBUS Slave. So when we talk about, just going to give a little overview on PROFIBUS. And so PROFIBUS is for customers that need to connect PROFIBUS devices to a lot of times non-Siemens PLCs or devices from other vendors, PLCs, HMI, drives, various valve control products from other vendors. And so PROFIBUS is a protocol that is used in implementing a lot of those solutions. We can also utilize PROFIBUS modules when looking to modernize some control platforms. If you've got some legacy systems out there that are using PROFIBUS, want to bring those into a newer control architecture that's potentially supporting Ethernet IP or Modbus TCP/IP. You can go ahead and modernize some of those architectures. And a lot of times it's really integrating dissimilar devices. You got devices from various vendors throughout the world, and you want to bring that information into either a Rockwell PLC or some other vendor over Ethernet IP, and really you need a protocol communication gateway. As far as some of the field bus protocols, PROFIBUS is by far one of the most widely used. Numbers vary depending on what study you look at, but one of the studies that had some information from a couple of years ago indicated that there were 22.8 million connected PROFIBUS nodes out on various industrial control systems. And if you compare that to just Modbus, that same study said 12.1 million connected nodes via Modbus. So it definitely is a widely used protocol. Provides for a field bus type protocol, provides high speed cyclic data, and so it gives you a deterministic data update rate. And so it's a very popular platform for getting small amounts of data in very high speed and deterministic applications. Some of those applications that we see in target markets are things for factory automation, such as automotive and material handling, as well as process control with some of the wastewater treatment systems, food and bev, oil and gas, mainly used on, we've seen it on a lot of drilling rigs. And then pharmaceutical industry also uses PROFIBUS as well. So wide range of use out there in the industry, and that's why it's a good protocol to use in implementing on some of those applications. So when we look at a typical PROFIBUS DP architecture, when we talk about a master, essentially a master device is the one that is controlling the bus, the PROFIBUS. And so devices such as HMIs, drives, even distributed I/O blocks will be sitting on something like a master, or our module would need to be a master talking to those various devices on the network. One of the things that we are excited to announce or premiere on this new product is this is our first module that actually supports the DLR device level ring. And so that gives you a redundant Ethernet network and allows you to participate on those DLR networks that have been widely adopted within the Rockwell automation platform. Compact Logix, Control Logix, all have options for DLR networks. And so it's DLR is a self-healing Ethernet, redundant Ethernet network. And so if you look at this diagram right here, you've got two green lines coming out of the Compact Logix processor. If you get a cable break anywhere in that network, the DLR network automatically can sense that and will automatically switch to the other port. So it gives you a seamless data transfer, even in the event of something catastrophic, such as a cable break. When we talk about a Profibus DP slave, typically the applications that we see on a Profibus DP slave is where we need to participate as a Profibus slave device on the network. And so, for instance, if you needed to pass data from a Compact Logix processor out to something like a Siemens Step 7 processor, so there may be things like a HMI drive and distributed I/O out on that network, and you need to pass that information over to a Siemens Step 7 processor from a Compact Logix controller. We do have some great functionality on the slave module that I'll get into a little bit more detail, where we now support a multi-slave, where we can actually emulate multiple devices on this network, and I'll talk about that in a little bit. So when we look at the module, just as a Profibus DP master, that would be our part number PLX51 PBM. And this module supports up to 1,536 bytes of input data, as well as 1,536 bytes of output data. So that gives you a lot of information. Keep in mind, Profibus is a cyclic data I/O network, and each slave is limited to 244 individual bytes. And so the network itself, this module can support up to 1,536, but in reality, most of the slave devices we see are transferring a lot less than 244 bytes of data. So you can get quite a bit of devices on a Profibus network just with this master module. One of the things that we did add in for this master module is it supports being either a Profibus DP master or a Profibus DP multi-slave, or it also can operate in quiet mode. And I'll get into a little bit more detail on what some of the advantages of that is right there in a little bit later on. Also, we took advantage of being able to support multiple Ethernet IP Class 1 I/O connections. So back to an Ethernet IP device, we can now support multiple I/O connections through there. So your data transfer back to the PLC is much faster. You don't have to worry about paging of data, and you can get data I/O updates of up to 10 milliseconds into a Ethernet IP Class 1 I/O connection. So we also, like I mentioned, are supporting device level ring, and so that gives you your redundant Ethernet connection. And in networks where you don't necessarily need the redundant network connection, you can use it as an embedded switch. So the module can go ahead and operate as a two-port switch, and so that helps to eliminate potential additional switches in a cabinet, or allows you to daisy chain other devices, other than Ethernet IP devices off of the module. And then this does take advantage of our PLX50 configuration utility, which is one of our newer utilities, and we've got some good features in there for getting these integrated into your system quicker. So I'll talk about that in a little bit as well. And so with the integration into Studio 5000, we utilize the EDS AOP, that's the electronic data sheet add-on profile. And that allows us to do up to 4 Class 1 I/O connections, each one of them with up to as fast as a 10 millisecond RPI time for all 4 connections. You can go ahead and import your network-defined L5X files, and so through the PLX50 configuration utility, you can build L5X files that you import directly into your PLC code. For the Rockwell Automation Studio 5000 environment. We can emulate up to 10 PROFIBUS DP slave devices, and so one of the things I mentioned earlier was a PROFIBUS DP slave is limited to 244 bytes of cyclic data. So in instances where you needed to transfer more than 244 bytes, typically what you had to do is set up DPV1 messages to do data table reads or data table writes of additional information. This required additional programming on a master device. And so what we do with our slave implementation of this module is we can emulate up to 10 PROFIBUS DP slave devices, each one of those transferring a maximum of 244 bytes. So this gives you high-speed cyclic I/O update rates and eases the configuration and the programming on the master side. And then one of the really nice features with this module is it's got a built-in PROFIBUS DP packet capture utility. So for anyone that's ever set up a Profibus network and had to start troubleshooting it because you had issues with getting communication between various devices, a lot of times that required putting a tap on the line and an additional piece of hardware to be able to take a look at the Profibus DP packets. This module has it built in, and so there's no need for additional hardware to do some advanced troubleshooting on the unit. So when we talk about the integration into Studio 5000, this is done using an EDS add-on profile. And so as you can see, you can define up to 4 Class 1 I/O connections, each one of those with a maximum size of 500 bytes of input data, 496 bytes of output data. So this is what allows us to transfer all 1,536 bytes of Profibus data over a high-speed Class 1 I/O connection back into a Ethernet IP processor. And each of those I/O connections can be specified as low as a 10 millisecond RPI time. And so when we talk about Profibus and Ethernet IP, typically those are two networks that in the past have they both require a lot of processing power to be able to keep up with the high-speed update rates. Profibus can run at a baud rate as high as 12 megabits per second, and Ethernet IP with your Class 1 I/O connections in this module, you'll be able to operate at RPI times of 10 milliseconds. Since the module utilizes EDS AOP for integration into the Studio 5000 environment, it does show up directly under the I/O tree and gives you status information, module information, allows you to utilize that just as it's a native module in the architecture. For Profibus master projects, one of the things that we've implemented within this module is the ability to generate Logix L5X files. And so this would be based on the Profibus configuration of the network. So essentially you utilize this PLX50 configuration utility to tell the Profibus master module what devices are out on that network and how much data to grab from each one of those devices. You can then go ahead and export a custom L5X file from this configuration utility, and it's going to automatically bring in the number of nodes that you've got on the network and the amount of data that's configured for each one of those nodes, and build out your UDTs and ladder logic to go ahead and copy that information over for you. So this is done using a import component function within the Studio 5000 software, or Logix Designer, Studio 5000 Logix Designer software. So you would go ahead and click on the File menu, Import Component, and then you would select a routine. This goes ahead and brings in all of your data types, your Profibus mapping for each of the slave devices that's configured on the network. And it goes ahead and builds a custom ladder routine based on your configuration that you've set up for the Profibus network, and goes ahead and copies that information over for you into controller tags that are predefined based on this L5X import. So really the benefit of this is just reducing the overall engineering time. You don't have to sit there and try and figure out what data is where, and you get a clearly defined tag within your Studio 5000 environment that lets you know, okay, this Profibus slave data, I've got 16 bytes of information from it, and it goes ahead and puts it into a tag for you. So really the purpose of this is to reduce overall engineering time and commissioning time. So the faster we can get these things integrated, faster you guys can move on to working on other stuff. So additionally, we've got a separate product, which is the PLX51 PBS. This module has a lower list price, also supports up to 1,536 bytes of input data. Essentially, this module has all the same functionality as the PBM module without being able to support PROFIBUS DP master. So as you're specifying a project, if you're not sure whether you need to be a PROFIBUS DP master or PROFIBUS DP slave, the PBM module is a good solution because it can operate in either mode. But in applications where you know that you're going to be a PROFIBUS DP slave, or you want to operate as a multi-slave, you can go ahead and specify this module, and it's going to give you all the same features and functionality as far as being able to support up to 4 Ethernet IP Class 1 I/O connections, being able to emulate up to 10 Profibus DP slave devices. Also gives you the device level ring or the embedded switch support. And again, it's configured through the PLX50 configuration utility, which is a download off of our website. So when we talk about Profibus multi-slave, again, like I mentioned, the limit of any Profibus DP slave device is 244 bytes of input data and 244 bytes of output data. For applications that require anything more than that, you typically had to take advantage of DPV1 messages, assuming that the slave device actually was a DPV1 device. And so that would allow you to do data table reads and data table writes that could be updated acyclically to the scheduled or the cyclic I/O data that was being transferred as part of that 244 bytes. This required additional programming in the master device, and again, since it was acyclic data, the update rate wasn't necessarily deterministic. It was just based on the bus and when they could get additional information out there. So with the multi-slave mode, we are able to emulate up to 10 independent nodes on the network. So there's still a single connection on the module. So as you're wiring the network out there, you're still wiring an individual Profibus connection to either the PBM or the PBS module. But in software, that module can emulate up to 10 unique node IDs on the Profibus network. And so this allows you to transfer up to the full support of 1,536 bytes of data, all as cyclic I/O data, without any additional DPV1 messages or additional programming in a master device. So it really does ease the configuration just by emulating multiple slaves out on the network, because at that point, when you go to configure the master, essentially you're going to pull the GSD file, which is generic station description. You're going to pull that into the master, and then you would just define multiple instances of that device because you're emulating multiple nodes. So that's a really nice feature that gives, for some slave applications, can give you much better performance than some of the other ways of doing it with DPV1 messages. Really eases the amount of setup and configuration that needs to be done. And then lastly, gives you update rates that are deterministic based on cyclic I/O data of the Profibus DP network. As far as the module itself, there's quite a bit of status information that's available through this PLX50 configuration utility. And so through the config utility, you can go in, look at the status of an individual module. It's going to tell you everything from your MAC address, your status on your Ethernet ports, whether or not DLR is being used. And then there's a couple of dip switches on the module that if you wanted to do something like a fixed IP address or lock out a configuration, you can go ahead and set those dip switches individually on the module itself. It's going to show you overall uptime of the module, as well as firmware revision and some other information there. So what we've found over the years in supporting these Profibus applications is the more information, status information that can be made available to users, the faster the commissioning time and the easier it is to troubleshoot units. I mean, we all like to think that every project's going to go perfect as we set it up and configure it, but the reality of things is once you get devices out on the network, there's sometimes issues that occur, and the more information, status information you can give, the faster we can get those installations up and running. So in addition to just the status information of the module, you've got general statistics on the Profibus DP network that shows you everything from packets received to packets transmitted, whether or not there were errors. Gives you some information regarding what your cycle times are and your hold time. And then also there's a live list. And so you could use the live list to go ahead and grab this or put a module out on the network and go ahead and determine what devices are out there and what devices are in data exchange or what devices are live and not in data exchange. So there's quite a bit of information that's available through the live list. Additionally, from a Profibus DP master perspective, one of the features that for us has been very helpful is just the ability to do a discovery. And this allows you to essentially plug a module on the network with a bunch of other devices, and it's going to come back and tell you what devices are on that network and what their ident number is or their unique identification number on the Profibus network and any corresponding GSD files that are associated with those devices. If there's a device that's on the network and not configured in a project, you can go ahead and add that newly discovered device to your configuration, And so if you've got application that's been up and running, you need to expand upon that. You plug a new device onto that network. You can then go ahead and do the discovery feature of the module and then add that device into the PROFIBUS DP master configuration there. There's also an event viewer for the module itself. And so this is basically allows you to look at the various events that have occurred on the module itself. This is a retentive event viewer. So things like a power cycle does retain this event log through a power cycle. And these events can be time-stamped. And so say, for instance, you get a issue that occurs at 10 o'clock at night. And so when the maintenance crew comes in the next day, or they get things back up and running, somebody can go back through and look through this event log, and it's going to tell you things like if the bus operation mode was set to offline, or if one of the Ethernet ports went down on the network. And so it's going to go ahead and give some detailed diagnostic data, which will assist in troubleshooting any issues that may occur on the network. And then lastly, one of the best features on this module is really the DP packet capture ability. And so like I mentioned before, if you had communication issues on your network, or you're having trouble getting a device up and running and into data exchange mode, a lot of times what you had to do is rely on third-party hardware, where you had to go ahead and install either a tap on the PROFIBUS network, or tee off one of the existing PROFIBUS connectors, and then run another external software package to go ahead and capture the PROFIBUS DP packets to get a clear indication of what really is going on within that bus. With this DP packet capture utility, this is provided in the PLX50 configuration software. So it will allow you to basically launch a packet capture directly from the software without any other standalone hardware. And then it gives you a detailed view for advanced troubleshooting of all the PROFIBUS DP communications on the network. And so you can capture up to a total of 10,000 packets for viewing. And this tells you the advanced PROFIBUS DP. It shows you your data that's actually being published on the PROFIBUS DP network. And so if there's any discrepancies between the data that's being received by a device and the data that's expected from a device, this is a great way of being able to determine what the cause of the issue is, what information is actually being sent by the PROFIBUS devices. And this packet capture utility is, like I mentioned, it's built into the PLX50 configuration utility. And so that information can be stored and sent off for troubleshooting. If you had to work with one of our support engineers to be able to support this, your application, you could send that information off. And it just gives a really clean, easy way of diagnosing PROFIBUS problems, and without having additional hardware on the network. So. Lastly, there's a third mode that you probably saw in one of my other slides, and it was the quiet mode. And so what quiet mode allows you to do is it allows you to actually sit on the network and look at the communications on the network, utilize the packet capture and some of the different statistics, and just allows you to determine what's going on the network before actually actively participating as a device on the network. So this feature right here all of the previous slides that show the event statistics, that show all the information on the PROFIBUS DP network, the packet capture utility, the live list. All of those are available in the quiet mode. So you can go ahead and if you've got a new installation that you need to add a module to, and you want to make sure that you're not going to disrupt any of the other devices that are currently in data exchange on the network, what you would be able to do is place this module in quiet mode on that network, utilize some of the diagnostic and packet capture utilities to look at the communications of that network and determine what devices are out there and what, for instance, what node address is not currently in use. And so you could use the live list that we showed earlier to determine what devices are out there. And you'd see that, okay, nodes 2, 3, and 4 are currently in use, so I'm going to go ahead and set up this module as a different node ID or node number 5. So that's another mode of operation that's in this module that, again, can help go ahead and help with getting applications up and ready as quickly as possible. So, all right. So, just as far as real quick FAQ, since we've been doing PROFIBUS modules for a long time, I know some of the questions that we've gotten just real quickly was whether or not this module is a drop-in replacement for some of our existing PROFIBUS units. And the short answer to that is no, it is not a drop-in replacement. When you talk about the PROFIBUS DP master environment, this utilizes a new configuration utility that you have to map your devices in. And then as far as a PROFIBUS DP slave, it does require a change on the master for a new ID number on the network. So it is not a drop-in replacement, but with our technical support team, we'd be more than happy to work with your customers if they're interested in migrating over from an older solution of ours or even a competitive solution to one of our new modules. So the other question is are the old ProLinx PROFIBUS modules end of life? These products are currently in a limited availability status due to some hardware component obsolescence that's going on. They will soon move to an EOL position, but for right now they are still available for some of the older PROFIBUS modules. And then really the main benefits, just to wrap up what some of the main benefits are, is really the L5X import into the Studio 5000 environment, the ability to operate as a multi-slave device on a PROFIBUS network, and that PROFIBUS DP packet capture utility is something that I know from some of the installations that I've worked on, always required doing any kind of advanced diagnostics, always required third-party hardware, and so being able to do this in a one hardware module definitely speeds up installation, commissioning time, and really makes things a lot easier for people that are implementing it. So. As far as some of the commercial collateral, this product is set to be released towards the end of this month, and we will have a product landing page, an external presentation, datasheet, user manual, and then we are working on a training video which will basically provide step-by-step updates on how to go ahead and configure the module and get it set up and running into your application. So with that, that was it. So I open it up to if there's any questions at this time. and give you guys a couple of seconds to ask any questions that may have came up. Okay, so I guess with no questions, I covered everything pretty well. What I was just going to do with, okay, I got one. There is a question that came in whether or not we had any plans to support other protocols. This first release of the module that we are releasing is going to be PROFIBUS DP to Ethernet IP. We will be coming out with a firmware release of this module later this year, and we'll have both PROFIBUS DP and the option to configure the second part of the network as either Ethernet IP, Modbus TCP IP, or Modbus serial. So, had another question that came in. Has this been used to pass through communications to a PA network via couplers such as a Siemens FDC 157? I'm not familiar with the FDC 157. I am familiar with the IM 157, which I think the FDC is the latest version of it. And since the coupler goes ahead and handles basically the conversion of the PROFIBUS DP messages to the PA network, we have been able to use it with those devices. I can look into some specifics on the FDC just to make sure how it configures on the network. But the pass-through couplers, essentially what they do is they map the PROFIBUS PA to a similar node address on a PROFIBUS DP network. And from our perspective as a master, it becomes transparent. So I will go ahead and double check on that for you and try and get some additional information on that. So since we got just a couple minutes here, I was just going to go ahead and go through, just give you a quick introduction into the configuration software. The configuration software, like I mentioned, is our new PLX50 configuration utility. And so what this can do is go ahead and this is how you set up your Ethernet IP communications. You can go ahead and configure your node ID on the network. You can configure the Logix device that you want to send status information to and the number of I/O connections that you need to support. From a Profibus perspective, you can set your highest station address, you can set your baud rate, you can set some of the failure status, how you want to, if you lose communication on either the Logix side, how you want to set those Profibus outputs, the data on that side. There are some advanced features for Profibus timing on the network. Really, we typically recommend sticking with the auto recommend settings unless you've got an application that requires some changes to like either the quiet time or the TQI or quiet time or TSET time, slot time interval, things like that. As far as adding a new Profibus DP device, that's done simply by going ahead and doing add Profibus DP device. You've got a device catalog which would show you all of the devices that are in your project folder. And so you would just go ahead and select a device in there, add that device into the network, and then this is where you would go ahead and set up your slot configuration, which is essentially where you're setting up how many bytes of input data as well as how many bytes of output data you want to exchange with the devices. So on various devices, this is all based on the GSD file, so something like a drive may have all this information mapped in as far as your start bit, jog, shuttle, as well as your speed index or reference parameters. And so that's all based in the GSD file itself. And so you could go ahead and add that device into the network. And at that point, you could go ahead and download this configuration directly to the module. You can go ahead and store that offline. If I go ahead and just do a quick download right there, it's going to show me very quickly that I just added a device here, node number 5. It's currently in a red condition because that device is not set up on the network. And so it gives you a quick visual indication of device status right there. As far as exporting your configuration files, as you add a new device into the project, you could go ahead and utilize the Generate Logix L5X. This will give you the ability to just go ahead and create a new export file, and I'll go ahead and save it with a new name, and put this right here, and save that. Now I've got a L5X file that I can then import into my Studio 5000 environment. So importing a new file into Studio 5000 is as easy as File, Import Component, and then I would select a routine. And I would go ahead and select my latest file here. Since I've previously imported this file, I will have to overwrite my existing one. The nice part about doing this as a import routine as opposed to some other way as far as like a import add-on instruction is that I can go ahead and overwrite this this routine online. And so it goes ahead and gives me the selection to overwrite. Within the environment, it tells me what changed right here. I've got a red flag right here, so I would want to make sure that I overwrite that. And then as far as all of my data types and my other components, those are all good. I can go ahead and tell it yes. And I can import my logic edits as pending. I can accept them. Or in this case, I'll just go ahead and finalize them and import the routine right there. And so this will go ahead and import my custom configuration file. And it takes just a second to go ahead and implement this. And so what I've done now is I've now got a custom routine that essentially does my data mapping, added my tag in here for a PLX51 PBS_1, which was based on the name I gave it right here. You can go ahead and it's actually recommended before importing, you can change this to something that's going to make a little bit more sense in your application. You could say node 5, you could say drive 3, whatever name you give it in this instance right here is going to be how it gets imported into the Logix environment. And then now we've got some controller tags in here that got automatically mapped in for us. And so in this instance, we'll have the input and output data directly into the processor. It creates that tag and those 16 bytes of information that we're getting from that device right there. So as you can see, as far as the Logix integration or Studio 5000 integration, does provide some great benefits that should help and speed up commissioning time. As far as there was one other question of how this compared to some of our in-rack solutions that fit directly in the chassis. With those modules, those provide a PROFIBUS interface directly into the backplane, so like a Control Logix or Compact Logix environment. This module integrates just as nicely into the architecture, but in a gateway. And so where it really provides some benefits is if you need to have a reduction in the overall Profibus cable run. So say, for instance, you've got a main control panel that's on one side of the factory, and you've got some of your Profibus devices that are somewhere else. Because it's a gateway solution over Ethernet, you can place the gateway close to those devices to minimize the amount of cable that you're running on a PROFIBUS DP network. And then at that point, you're just bringing an Ethernet connection back. As far as speed, data update rates, and some of the feature set, I think this module competes with or adequately supports the same applications as some of our other ProLinks or in-chassis modules. The data size on some of the applications may be different as far as the number of Profibus bytes that are supported. That's actually something I can go ahead and put into our FAQ that how it looks as far as the number of bytes that are supported, especially when compared to something like our ILX69 PBM, which is the Profibus master for compact logics that we released recently. So but that was really about it. I appreciate everybody's time and had some good questions in there. I'll follow up on some of those. And if you have any questions about this module or any of the Profibus applications, anything we can help with, please feel free to reach out to our technical support team. And we look forward to getting this out there and helping to solve some of the advanced communication with Profibus networks for you guys. Thanks, everybody.